Hello and welcome to Mr. Linford's math course. In today's discussion, we're going to be going over an introduction to the concept of sets. We're going to briefly talk about what sets are and define them. We're going to look at the notation, the general notation, I should say, for writing sets, as well as going over some concepts that relate to these, such as subsets and more specifically the null or empty set. Now let's first begin by talking about what a set is. There are many different definitions to sets, some very sophisticated definitions. For this class, we're just going to work with a more workable definition, and we're going to say a set is a collection of elements. A collection of elements. Now, what do I mean by this? I'm not referencing elements. Sometimes people think I'm talking about the table of contents from chemistry class or elements being some type of matter. No, I don't mean anything like that. A set can really be a collection of almost anything. It's a collection of things. And the things that we have built into the set are just simply called elements. Elements could be numbers. In geometry, they can be points. They can be shapes. We can even have categories for elements. Picture, if you will, let's say we were categorizing all the people of Michigan. Let's say we were taking the census and we, on the census, surveyed all people of Michigan. Or maybe we'll say at a smaller level, all people of Ann Arbor, Michigan. Okay? We can have the list of all the people named on the census as a set. Let's say you worked at a clothing store, and let's say in your database you had a list of all the inventory of, let's say t-shirts, graphic t-shirts. Okay, that would be a set. You would have a set of all the graphic t-shirts that you have in stock. So a set can be numbers, it can be shapes, points, it can even be categorical stuff. Okay? In this class, we're going to work with sets as numbers. Now, the notation for this is, we're going to start, I guess I should say, in a more general sense. Okay? There's going to be several different ways of writing sets. One in particular that we're going to get to in another video. But first, we should go over what the general method is of writing a set. So, to write a set, list the elements. So list the elements in curly braces. That's what these are, those curly braces. You should see them on the keyboard, on your laptops. You can see them on your phones. So be able to write these curly braces. They look, like this. Okay? We're going to list the elements in these curly braces and separate the elements with commas. Okay? So let's do an example of this. Let's say I wanted the set of numbers 1, 2, and 3. Okay? Let's say I wanted to write that set, the set of 3 numbers 1, 2, and 3. I would write a curly brace, and I would list 1, 2, and 3, and I'd separate them with commas. Okay? So I've separated all 3 elements. This is a set of just 3 elements, okay? And I've written them in the curly braces. Now, like I said before, this is a set of just 3 elements. There are no elements in between here. So for example, you might say, well, what about 2.5? Is that in the set? No, it's not, because I didn't write it. What about the number 0? Is that in the set at all? No, because it's not written. The set is literally just the elements that I wrote. There are other ways of writing sets to include more elements than what you wrote, but that's going to be for a later video, okay? Right now for a set, it's literally just the elements that you write down. Now that we've defined sets and have a framework of understanding of what they are, let's shift into talking about subsets. Subsets come from sets. We're going to define a subset as a set B is a subset of set A if all the elements of B, or I should say in set B, are elements of set A as well. What do I mean by this? Well, for something to be a subset, all of the elements of it must also be in another set. Think of a subset as like a subcategory, okay? We can say that B is a subset of A. This is the symbol for subset. That's the notation for it. It basically means it's a sideways U with a line under it. That means is a subset. When we say this, we mean it's a subcategory. So let's say the general set A here is the set of all people living in Michigan. Okay? Let's say the set A is the list of all people that live in the state of Michigan. Set B, being a subset, we could say that this might be the set of all people living in Ann Arbor, Michigan. Okay? So the set of all people living in Ann Arbor, Michigan is a subset or a subcategory of all the people living in Michigan. Okay? Think of it almost like if you worked at a department store or a retail shop. Let's say you had the list of all graphic t-shirts. Okay? A subset of that might be all graphic t-shirts that are also blue. Maybe you have the set of all sweatshirts that your store sells. A subset of that would be the set of all hooded sweatshirts that your store sells. Maybe you would say a subset could be the set of all crew neck or V-neck sweaters, the set of all cardigan sweaters, the set of all red sweaters. Okay, a subset is really a subcategory. Okay, as long as you can show that all of the elements of the subset are elements of the other set, then you showed that it's a subset. Hopefully this is making sense. Let's go ahead and do an example, though, to get a better understanding of this definition. Let's go ahead and take a look at this example here where the set involves numbers, and we want to list the subsets of the set 1, 2, 3. Okay, so what are some subsets of this? Well, one subset could be the set 1 and 2. This is a subset of the set 1, 2, 3 because the elements in here are also elements in here. So it's a subset. We're good with that. Now let's see what else we can come up with. Why don't you pause the video, take a couple minutes, and see if you can jot down as many subsets as you can find from the set 1, 2, 3. All right, well, hopefully you had some time to work through this. But let's see what other examples we can come up with. Well, we already did the example where we just took the numbers 1 and 2. Well, let's maybe now take the numbers 2 and 3. So we can have the set of just 2 and just 3. We could also have the set of just 1 and just 3. I want to point something out for a minute. Sometimes people think, what if I listed, in addition to this, the sets 2 and 1, and the sets 3 and 2, and 3 and 1. Are these sets any different than these? That's the question here. Are they any different? Well, in fact, no, they're not. These sets are equal to each other, okay? So just reordering the numbers, reordering this group, doesn't actually make it a set, okay? So, or any different of a set. So we're going to not do that. We're going to stick in the order. And by the way, we generally like to write things in like chronological order, alphabetical order. Here we like to write it in increasing number order. Okay? So we have the sets 1, 2, 2, 3, and 1, 3. Now we need to figure out, are there any other subsets? Well, in fact, we could write the set of just one element. This is a subset of the set 1, 2, 3, because its element is a part of the larger set. I never said that you couldn't have one element. That's totally allowed. So we could have the set of just 1, the set of just 2, and the set of just the number 3. So it looks like we have all the combinations that are possible. We have each number individually. We also have the pairs 1, 2, 1, 3, and 2, 3. Are there any other subsets that we could list? Well, it turns out yes. We can list the subset 1, 2, and 3. Now some of you are probably saying, wait a minute, Linford, that's what the original set is. Can you list it as a subset? Pay attention to the definition. We can say that the set 1, 2, 3 is in fact a subset of itself because the definition only said as long as all the elements of the one set are a part of the other, then it's a subset. So I think this is something important for us to note. So I'm going to put a little asterisk right here, and I'll write down here, any set is a subset of itself. So you can say that any set is a subset of itself. So if you had to have an example of a subset for 4, 8, 16, 32, well, you could say a subset of that is the exact same set. Okay? Every set is a subset of itself. And that just comes from the definition. Now, hopefully something you're realizing about this is that all of these sets are either the same size as the original set or less. Okay? I cannot have a subset for the set 1, 2, 3 that contains 4 elements. That's not possible. Okay? Because at most I can just list 1, 2, 3. I can't add anything else in. And you can't double list elements. Don't write something as 1, 1, 2, and 3. That doesn't count because we don't double list elements in a set. So that's the idea of subsets. Hopefully this is making sense, and maybe I should write that last part down. A subset is either the same size as I'll call it the original set, or smaller. Either it has the same number of elements or it has fewer elements to it. Now, let's pause about this topic of subsets for a minute, and let's talk about another topic that pops up in sets. This is a particular type of set called the null set or the empty set. Okay? The null set or the empty set can be defined as a set with no elements. So a set containing no elements is the null set or the empty set. Okay, that's the idea for this. There's nothing to it. The notation for this, let me write down notation here. We can use the symbol a 0 with a slash through it, or you can use the symbol of two curly braces with nothing in them. These both reference that you have a set containing no elements. I'm going to put a little note here because I see this quite often. Do not write curly braces with a 0 to mean the empty set. Oops, let me rewrite that. Curly braces with a 0 is not the same thing as curly braces that are empty. The reason is, and a lot of times people get confused with this, they say, well, doesn't 0 mean nothing? No, it doesn't. 0 is a number. This right here is a set with one element in it, the element 0. In counting, right, 0 means nothing, if we think about it like that. But 0 is a number, just like 1 or 2 or 3, okay? This is a set with one element in it. So it's not the empty set. The empty set literally would have nothing in it. Now, sometimes some textbooks might use null set, some might use empty set. In more recent publications, some books have distinguished between the null set or the empty set and when to use them. However, most textbooks out there, like I'd say probably 3/4, if not more, of most math textbooks, use these terms interchangeably. So I'm going to use them interchangeably as well. So that's the idea of the empty set, a set with absolutely nothing in it. You can think about this again, like if we had our retail example. Let's say you're working at a store, a retail shop, and someone asks you if you have any of these particular t-shirts in, oh gosh, let's say green. Okay? So you check the database. You check the set of all t-shirts that you have and you see if there are any greens. And it turns out no, they don't make that particular t-shirt in green. You would say that that is an empty set. The set of these particular t-shirts that are green would be empty because they don't make them. That's a way that you can think of what the empty set would be. What I want to point out to you is a very special topic about the empty set. Let's go back to talking about subsets really quick. You might say that this is the list of all subsets for 1, 2, 3. However, we're missing one. The empty set is also a subset of the set 1, 2, 3. In fact, let me put a little star here, and I'll write this down at the bottom. The empty set, or the null set, is a subset of every other set. So anytime you're listing subsets of a set, the null set happens to be one of the subsets. So we literally could write here that the empty set is a subset of 1, 2, and 3. If you're curious about why this is, go ahead, send me an email, let's talk about it. I might make a video later going into a little more explanation of why this is. It's kind of, it all comes down to what's called being vacuously true. okay? Which is kind of a lesser form of truth. And it plays around with how you can prove a statement is false or prove a statement is true. So it takes a little more explaining, and I can do that if you're curious. Feel free to contact me, but I'll try to make a video later on explaining this. But just for the time being, keep in mind that the empty set is a subset of any other set, okay? So if someone asked you, give me a subset of whatever set, you could say the empty set works out as one of the subsets, okay? Just something to keep in mind. One other thing I wanted to talk about. Now we have the collection of all the subsets to 1, 2, 3. You could list all of these as one giant set. You can have a set of sets. That's allowed. So all of these together make what's called the power set. The power set is the set of all subsets to a set. Have I used that word enough lately? So power set is the collection of all subsets to a set. So like if I said, tell me the power set of 1, 2, 3, you would just list out all the possible subsets of 1, 2, 3, including the empty set. Okay? That's just another terminology I feel like mentioning because they sometimes bring this up in the book. This is the idea of what it means to be a set. Okay? It's a collection of elements. A subset, think of that as like a subcategory. Okay? And then the empty set, just realize that you can have sets with nothing in them. So if you have any questions about this or comments or want me to explain any more about this, feel free to contact me. My email is klinford, that's KLINFORD, at wccnet.edu. Let me know what you thought of the video, if you have any questions or comments, and until next time, take care.